Good morning, students. Hope you're fine, doing fine. Okay, okay. Dear students, I will continue next chapter also. Actually, we have completed chapter number 9, chapter 10, whereas this chapter number 11. Name of the chapter is Dual Nature of Radiation and Matter. Dual nature of radiation and matter. You know, dual means both, like this and like that. Of radiation. What is radiation and what is matter? This is 6th chapter, whereas 1 5 mark question usually asked in theory part. Long question, 5 marks question will be asked. I mean, one question carrying 5 marks will be asked on this chapter. Rarely, 5 marks is divided into 2 parts, like one 3 marks question, one 2 mark question. One 3 marks question, one 2 marks question. Anyway, this chapter is quite easy and interesting. We studied in chapter number 9 ray nature of light or particle nature of light, considering ray or light as a particle, corpuscular theory. Whereas in chapter number 10, we have considered our our light as a wave. By considering light as a ray, we can explain some of the phenomenon like diffraction, reflection. Okay, where where your size of wavelength is not comparable with the size of matter it interacts, usually behaves as a radiation. Ray. Whereas when disturbance is considerable with respect to size of wavelength of your light, then we can see wave nature of light. Wave nature of light. So, ray nature of light is usually classified as a macroscopic phenomena, whereas the wave nature is usually considered as microscopic phenomena. Now, question is, what exactly is light? Light is a particle or a wave? The answer for this question is given in this chapter. It's like a conclusion. Chapter number 11 is like a conclusion for your all doubts. As far as chapter number 9 is concerned or chapter number 10 is concerned. Maxwell, by his electromagnetic equation, considering equations of magnetic field, electric field, and applied to optics, proved light as a electromagnetic wave. He just suggested by his mathematical equations light as an electromagnetic wave. Heinrich Hertz able to generate, propagate those electromagnetic waves. Maxwell suggested the things, but your Heinrich Hertz actually generated your electromagnetic waves. While studying electromagnetic waves only, while studying electromagnetic generation and propagation, we usually say, while studying generation and propagation of electromagnetic waves only, electromagnetic radiations, let us use the term radiation, electromagnetic radiation, okay, Xray, okay, radio waves we have, micro, infrared, okay, visible light, all these are electromagnetic radiations. Heinrich Hertz, while studying propagation and generation of these electromagnetic waves, noticed one more phenomenon. That phenomenon is called photoelectric effect. Photoelectric effect or photoelectric emission. He just noticed that. He discovered that there is something strange happening while studying detection, generation, and propagation of electromagnetic waves. Here, a scientist so-called Roentgen discovered X-ray. X-ray or fast-moving particles, correct? Fast-moving particles with a very high frequency and wavelength, all those things. Fast-moving particles, electromagnetic, it's photon, form of photon. Roentgen discovered X-ray in 1895. 1895. Remember? J.J. Thomson proposed a theory, proposed a model. We have to study the model in next class, the next chapter, chapter number 12, where he discovered electron after 2 years later, 1897. At the same time, see here, photoelectric effect was observed by Heinrich Hertz in 1887. See the year, 1887. It's 1895. Early in 1887, Heinrich Hertz observed this photoelectric effect. What is photoelectric effect? We will discuss it later. But remember, he observed something strange. Something strange which cannot be explained with the help of wave theory of light. Whereas he was working to detect electromagnetic waves, electromagnetic waves. He observed some strange thing in 1887. Just noticed. X-ray, Roentgen detected X-rays, form of particle, photons. You know what is the application of X-ray? If you don't know, we'll discuss it in chapter number 8. Okay, Judge sir will handle it. No problem. We will discuss it neatly. Remember this X-ray, detection of X-ray and electron gave idea about deep nature of your atom. We can understand atom better at that time by using the J. Thomson model as well as X-rays. At the same time, around 1879, see the year 1879, William Crookes, name of the scientist, British scientist, observed some cathode rays. What are cathode rays? We will discuss it. Some cathode rays. You know cathode rays better. William Crookes. All this led to one more new concept, phenomenon called electron emission. Electron emission from some surface, usually surface of a metal. Emission or liberation of electrons from some special materials, say metals, by applying some kind of energy is called electron emission. What is electron emission? Electron emission means emission, taking out electron from metal surface. When some radiation, some light is incident on it. If light is incident on some material, some metal, surface of metal, remember metal, and if you are watching light as a wave, if you are still considering light as a wave, emission of these particles, so-called electrons, as detected by J.J. Thomson, was impossible to explain. That time it is now even it's impossible to explain that procedure, that phenomenon, that process. So the total These were some observations. See, remember, this photoelectric effect was observed by Heinrich Hertz. At the same time, there are two more scientists. We have to name them. One is Leonard Hallbach. Leonard and Hallbach, we have to study once again their observations also. They observed same phenomena where they observed emission of electrons from some metal surfaces when some radiation is incident on them. Let me repeat. When some radiation, electromagnetic wave, electromagnetic radiation, best term, electromagnetic radiation is allowed to fall on some metal surface, they observe emission of electrons, emission of negatively charged particles, electrons, which if allowed to flow through a particular direction constitute current, and that current due to these electrons, when some radiation is incident on some metal, the current then called photoelectric current. That current is called what? Photoelectric current. Photoelectric current is due to those electrons. Which electrons? Electrons which are liberated when some radiation is incident on some metal. Those electrons are called photoelectrons. Photoelectrons. The theory was not very easy to understand that time. Then there, what we call, there came a person, very famous, young scientist of that time, so-called all-time genius, Albert Einstein. Albert Einstein. In 1905, explained these phenomena. This phenomenon of electromagnetic, photoelectric emission. This phenomena of what? Emission of electrons from metal surface. By applying Max Planck's Planck's theory, Max Planck's photon theory, where once again we are supposed to consider your radiation as a particle, individual particle, quantized particle, having energy, each particle having energy E is equal to h nu. That theory was called Planck's quantum theory. Albert Einstein, just with the help of Max Planck's quantum theory, explained this photoelectric effect, this photoelectric emission, this electron emission, by considering light as a quanta, light as a particle, packet of energy. How? We will discuss it. For his brilliant investigation, Albert Einstein got Nobel Prize. But in 1921, 1 year later he received, anyway 1922, he received Nobel Prize. He was given Nobel Prize for his achievements in theoretical physics as well as explaining photoelectric laws very neatly. That time, once again, light took particle nature. By Max Planck's quantum theory, black body radiation theory, we have studied chemistry. And your Maxwell's electromagnetic theory, confusion arised. Is light, is wave or matter? Is wave or matter? I mean, wave or particle? The conclusion was dual nature. Your radiation behaves as a matter, your radiation behaves as a matter, your matter behaves as a radiation. A moving matter is associated with some wave. A moving matter is having some wave. That wave is called matter wave, which is along moving matter. Matter waves are introduced. Matter waves are introduced. We have to study even matter wave. De Broglie, one of the most important scientists, we have to study this chapter, introduced a concept called matter wave, de Broglie wave. That's why I said this is a conclusion. This chapter is like a conclusion. Dual nature of radiation. Radiation behaves as a matter, matter behaves as a radiation. Your light behaves as a particle as well as wave. It has dual nature, duality is the concept. Okay? See, this is just introduction part. No need to remember all these things. Okay? Just introduction. We will start actual chapter now. Okay. Concept is specific charge. We'll start with the concept called specific charge. Specific charge. Specific charge. What is specific charge? We will discuss only for one more question. One mark ke matra agust discussion ಮಾಡುವ specific charge is a big concept actually. Specific concept of specific charge was given by J.J. Thomson again. The concept of specific charge was given by J.J. Thomson. What is specific charge? We define specific charge as, for one mark only remember, we define specific charge as it's a ratio of charge of a particle, charge of an electron, better, charge of an electron to its mass. Specific charge, okay, specific charge is defined as it's a ratio of charge of the electron to charge of the mass of the electron. What is electron charge? From chapter number 1 and 2, we are very well versed with this concept, this value. The charge on electron is basic charge, which is what? 1.6 into 10 raised to minus 19 coulomb. What about electron mass? Electron mass is around 9.1 into 10 raised to minus 31 kg. Correct. Divide ಮಾಡಿ, like it's a constant. You have to remember this constant. It's around 1.76 into 10 raised to 11 coulomb per kg. 1.7 is important. 1.7 into 10 raised to 1.7 into 10 raised to 76 10 raised to 11 coulomb per kg is the value of specific charge. This value of specific charge. Please remember, students, from this chapter onwards, chapter number 11, chapter number 12, chapter number 13, chapter number 14 is quite easy nowadays. Most of the things are deleted. Okay, these chapters you are supposed to remember maximum data numbers. We have to remember. Okay, please be careful. These are easy chapters, no doubt. Chapter number 11, 12, and 13. But we have to remember certain things very carefully. Okay, this is what specific charge. And one more thing let me mention here. Charges are quantized. At the same time, a scientist called Millikan, by his oil drop experiment, proved a charge is quantized. Charge is quantized. And value of that charge is 1.6 in 10 raised to minus 19 coulomb. Name of the scientist is Millikan. The experiment is oil drop, Millikan's oil drop experiment. Okay, please remember. Now, next part. What do you mean by electron emission? We will discuss something about electron emission. We just discussed somewhat some new term called electron emission. What do you mean by electron emission? What do you mean by emission? Coming out of certain surface. Usually, metals have Lots of free electrons. What are free electrons? These are outermost electrons, valence, valence electrons, free electrons. At room temperature, they are very much free. Chapter number 3, you have discussed all these points. At room temperature, they are very much free and they are moving randomly. Correct? These electrons are free. That's why they are called free electrons. If they are given some direction, say electric field is applied, they will flow in particular direction, creating a electric current. Flow of those charges, what results in electric current. Now question is, what if you want to take out some free electron from metal surface? ಅನ್ಕೊಳ್ಳಿ ಇದೊಂದು ಮೆಟಲ್ ಅಂತ, ಈ ಮೆಟಲ್ ಅಲ್ಲಿ ನಮಗೆ ಗೊತ್ತಿದೆ ರೂಮ್ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ನಂಬರ್ ಆಫ್ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ದಾವೆ, ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ದಾವೆ. ದೇ ಆರ್ ಫ್ರೀ, ದೇ ಆರ್ ಮೂವಿಂಗ್ ರ್ಯಾಂಡಮ್ಲಿ. ಓಕೆ, ಅವು ಫ್ರೀ ಆಗಿರ್ತವೆ. ಒಂದು ವೇಳೆ ನೀವು ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಈ ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಇಂದ ಹೊರಗೆ ತೆಗಿಬೇಕು, ಏನಾಗುತ್ತೆ ಅವಾಗ? Imagine if by some means an electron tries to escape from this metal surface. I am using term metal surface. Remember metal surface. I am now very much sticking to metal surface only, metals only, metals. Okay. Imagine you are trying to remove some electrons, single electron from this metal surface. What you observe? When electron is removed from this metal surface, this surface acquires positive charge. Electron is negatively charged particle, we know. Your surface acquires positive charge, and hence this electron is recollected, or it is taken back by the metal surface. It's taken back by the metal surface. When we try to take an electron, or electron itself tries to go away from that metal surface, the whole surface will acquire positive charge, or that atom will acquire that positive charge, and it will re-attract that electron. So there is no question of an electron to come out from this metal surface. ಹೀಗಾಗಿ ಯಾವುದೋ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ತನ್ನಷ್ಟಕ್ಕೆ ತಾನೇ ಹೊರಗೆ ಬರೋ ಸಾಧ್ಯತೆ ಅಂತೂ ಇಲ್ಲವೇ ಇಲ್ಲ. ನೀವು ಹೊರಗೆ ತರಲೇಬೇಕಾದ್ರೆ ಏನು ಮಾಡಬೇಕು? Of course, you have to supply energy, or in other words, you have to work on this metal surface. To remove electron forcibly, such that the attraction between this positive charge and negative charge, to overcome that force, you have to apply some energy. Some work is to be done. This work which you are supposed to do to remove electron from metal surface is called work function. Is called work function. Is called work function. Phi naught. Let us represent it by phi naught. Sometimes it's represented by W in some textbook. In some subject W naught. Phi naught. Don't confuse. Phi naught. Everywhere we use same. For your chapter number 2. Also we use in pi. Chapter number 1 we are using pi. Chapter number 1 we are using pi. What is pi in chapter number 1? Electric flux, magnetic flux. Okay, there is the same notation. Phi naught represent work function. Represent what? Work function. What is work function then? The minimum energy. See here, this is electron. The minimum energy in the form of radiation, of course. This is radiation. Energy supplied in the form of E is equal to h nu, where h is Planck's constant, nu is frequency of your radiation. The minimum energy required to liberate this electron, liberate this electron from metal surface is called work function. Or the minimum energy required by this electron, the minimum energy required by this electron to move away or to emit from this metal surface is called work function. Or the minimum work you are supposed to do in order to remove this electron out of this metal surface is called work function. Or it is the minimum energy required by this electron so as to come out from metal surface is called work function. Work function listed. ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಒಂದು ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಇಂದ ಹೊರಗೆ ತೆಗೆಯೋದಕ್ಕೆ ಬೇಕಾದ ಎನರ್ಜಿ ವರ್ಕ್ ಫಂಕ್ಷನ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಯಾಕೆ? ಇಟ್ಸ್ ಅ ವರ್ಕ್ ಎನರ್ಜಿ ಥಿಯರಮ್. whenever you do work it's converted into energy. whenever you do energy there is some work energy theorem. The minimum energy required, minimum term used is minimum energy required to remove, just to remove this electron from this metal surface. Remember, in this electron emission, okay, what we study? We study when a radiation, what radiation we will discuss in next step. A radiation in the form E is equal to h nu. E is equal to h nu is a photon, you know. Is nothing but photon. As suggested by Max Planck. By using the wave theory, you cannot explain this phenomenon. This emission of electron is not at all possible by taking light as a wave. Here you have to consider light as a particle. That is the theme of this chapter. Light behaves as a wave in chapter number 9 and chapter number 10. Whereas here we observe, this is photoelectric effect. This effect is called photoelectric effect by using radiation. Okay. Here your light behaves as a particle, as a photon with energy E is equal to h nu, where h is Planck's constant, nu is frequency. The amount of energy required to just to remove an electron from metal surface is called your work function, phi naught. Usually represent work function by h nu naught. Phi naught is equal to h nu naught. Where nu naught, I will explain. In nu naught is called threshold frequency. Where nu naught is called threshold frequency. H is Planck's constant. Planck's constant. Probably in notes I have not given this point. Please, you can just add this point also. Or phi naught is equal to h nu naught. We know what? We know this, probably you know this. C is equal to nu lambda. Nu naught lambda in this case. Or nu naught is equal to C by lambda, or phi naught is equal to Hc by lambda. This is also very important. Hc by lambda. Or you can even write as lambda naught. Threshold wavelength we can use. Okay. These two forms are very important. Pi is equal to h nu naught, or pi is equal to Hc by lambda or lambda naught, whatever it is, lambda naught or lambda. Okay, probably in notes I have not given these 2 points. Okay. We are discussing about electron emission. Okay. One thing is clear. I will write one by one. This is a work function. Work function. I have to mention this. Work function. Say phi naught is equal to h nu naught. Second thing, the minimum energy required to this electron from metal surface is called threshold function. I mean work function. SI unit of work function is SI unit of your work function is usually it's a joule, whatever it is, it's joule or joule, J only. But there is practical unit also. There is practical unit also. Usually your work function is measured in terms of electron volt. Electron volt is a practical unit of your work function. Remember. Very important point I am telling. While solving problems, you are given most of the problems as far as your work function is concerned in electron volt only. Or you are asked to convert electron volt into joule into electron volt. The practical unit of your work function is electron volt. Let me repeat. Your practical unit of work function is electron volt. SI unit is joule or joule, whatever it is. Second is electron volt. One EV. This is important definition. Define work function. Define electron volt is also important question. For 1 mark, all questions 1 mark. What do you mean by electron volt? Okay. We know potential difference is given by chapter number 2. Work done in bringing a unit charge from one point to another point. W is equal to VQ. Correct? Potential difference. V is equal to W by Q. You know this formula very well in chapter number 2. Starting the level one formula. What is work function here? If W represents your work function, this is W represents your work function, then W is equal to what? V into Q. Where A is electric potential, I mean the potential difference, Q is charge. If you consider this charge as an electron, then W is equal to E. You get this equation. Where W represents your work function, EV, electron volt. What is electron volt? I will define it first. Electron volt is defined as it is a acceleration acquired by electron by applying potential difference of 1 volt. When potential difference between two terminals is 1 volt, the acceleration acquired by electron is called electron volt. Is called electron volt. 1 second. Or electron volt is energy gained by an electron. That's the term. Electron volt is energy gained by an electron when it accelerated by applying potential difference of 1 volt. The best. Anyway, we have to consider energy or work term must. Electron volt is energy gained by an electron when it accelerated by applying potential difference of 1 volt. That is, you know, W is given is a work we measure in terms of joule. Correct? What is the relation between joule and electron volt? If it is joule, See, 1 electron volt is equal to E. E means basic charge on electron. It is nothing but 1.6 into 10 raised to minus 19 into 1 volt. ಇದು 19 coulomb alva, coulomb into 1 volt. Correct? Visible, not visible. I will write here. Electron volt and ಗೊತ್ತಾಯ್ತು ಬರುತ್ತೆ. Electron volt ಅಂದ್ರೆ ಏನು? It is the energy acquired gained by electron when electron is accelerated by applying potential difference of 1 volt. By applying potential difference of 1 volt. Now question is, what is the relation between your joule and electron volt? Let us try to understand. If we measure electron volt in W is equal to EBC, W is equal to EV alpha, W is equal to EV. If E is equal to 1.6 into 10 raised to minus 19 coulomb into V 1 volt, then E is equal to alpha, W is equal to alpha, is equal to 1.6 into 10 raised to minus 19 electron volt. Sorry. This is coulomb volt, correct? C into E is a unit. This is W. W is equal to this much. You have to remember this. You have to remember this. Please note, you have to remember this. Okay. Okay. Or 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules I can get. Correct? This is very important. 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. Very important. Very important. Please remember this value. Probably ಇದನ್ನು ನಾನು ಬರ್ಸ್ತಾ ಇಲ್ಲ ನೋಟ್ಸ್ ಅಲ್ಲಿ. ಇದು ನಾನು ನೋಟ್ಸ್ ಅಲ್ಲಿ ಕೊಟ್ಟ ಹಾಗಿಲ್ಲ. Please mention this also. ಇದನ್ನು ಬರ್ಕೊಳ್ಳಿ. Okay. 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. While solving problem, this is very important. While solving problem, this is very important. Okay. ಇದು actual form J ಬರಲ್ಲ easy conversion. 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. Very important. And that's very important. Okay? Fine. Here I will write 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. This is important. This is important. What we are discussing? We are discussing electron emission. Under electron emission, we discussed these 2 points. First one is electron work function. What is work function? It's minimum energy to remove the electron from metal surface. What is electron volt? Electron volt is a unit of energy or work function. Okay, you know the definition and don't we know the conversion. Okay. Now question is, what are different probabilities to remove electron from metal surface? How we can remove electron? One thing is common. One thing is very much clear. What? By supplying energy. By supplying energy to metal surface, you can remove electrons. Let me repeat. ಈಗ ನಮ್ಮ ಹತ್ರ ಪ್ರಶ್ನೆ ಅಂತಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಷನ್ ಆಗ್ತದೆ ಅಂತ ಆದ್ರೆ ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಇಂದ ಹೇಗಾಗ್ತದೆ? Of course, ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಇಂದ ಹೊರಗೆ ಬರಬೇಕಿದ್ರೆ ಅದಕ್ಕೆ ನೀವು ಶಕ್ತಿಯನ್ನು ಕೊಡಬೇಕು. ಯು ಆರ್ ಸಪೋಸ್ ಟು ಪ್ರೊವೈಡ್ ಎನರ್ಜಿ. ಈ ಎನರ್ಜಿಯನ್ನು ಹೇಗೆಲ್ಲ ಪಡಬಹುದು? What are different possibilities to supply energy? So there are different types of electron emission. There are different types of electron emission. So our third concept is types of electron emission. Electron emission. So third concept is types of electron emission. I read it as very important. ಒಂದು 2-3 ಸಲ ಬಂದಿದೆ. 2 ಮಾರ್ಕ್ಸ್ ಬರ್ತದೆ. ಯೂಶುವಲಿ 2 ಮಾರ್ಕ್ಸ್ ಬರ್ತದೆ. 2 ಮಾರ್ಕ್ಸ್ ಬರ್ತದೆ. ವರ್ಕ್ ಫಂಕ್ಷನ್, ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್, ಟೈಪ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಷನ್. ಟೈಪ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಷನ್ ಯಾಕೆ ಹೇಳಿದೆ ನಾನು? ನಮಗೆ ಗೊತ್ತಾಯಿತು ಎನರ್ಜಿ ಸಪ್ಲೈ ಮಾಡೋದ್ರಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ ಹೊರಗೆ ಬರ್ತದೆ ಅಂತ. ಹೊರಗೆ ಬರೋದಾದ್ರೆ ಎನರ್ಜಿನ ಹೇಗೆ ಸಪ್ಲೈ ಮಾಡಬಹುದು? ಫಸ್ಟ್ ಒನ್ ಈಸ್, ಅಲ್ಲಿ ನೋಡಿ ಇಲ್ಲಿ ಬರಿತಾ ಹೋಗ್ತೇನೆ. ಫಸ್ಟ್ ಒನ್ ಈಸ್ ಟೈಪ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಷನ್ ಅಲ್ಲಿ thermionic emission. Thermionic emission. Second one is field emission. Third one is photoelectric emission. ನಾವೀಗ ಏನೇ ಅಭ್ಯಾಸ ಮಾಡಬೇಕು? ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ಹೊರಗೆ ತೆಗೆಯುತ್ತಿರೋ ಬೇರೆ ಬೇರೆ ಮೆಥಡ್ಸ್ಗಳು ಯಾವುದು ಅಂತ. 3 ಮೆಥಡ್ಸ್ ಇದ್ದಾವೆ. ಆಕ್ಚುಲಿ 4 ಮೆಥಡ್ಸ್ ಇದ್ದಾವೆ. ಮತ್ತೊಂದು ಬರ್ತದೆ ಸೆಕೆಂಡರಿ ಎಮಿಷನ್ ಅಂತ. ಅದನ್ನ ಸ್ಟಡಿ ಮಾಡಲಿಕ್ಕೆ ಇಲ್ಲ. ಸೆಕೆಂಡರಿ ಎಮಿಷನ್ ಮತ್ತೊಂದು ಮೆಥಡ್ ಇದೆ. 3 ಮೆಥಡ್ ಸ್ಟಡಿ ಮಾಡಬೇಕು. ರೈಟ್ any 2 types of electron emission. Very famous question. ತುಂಬಾ ಕಾಮನ್ ಆಗಿರೋ ಕ್ವಶನ್. Write any 2 types of electron emission. ನೀವು ಯಾವಾಗ ಹೆಸರು ಬರೆದ್ರೆ ಸಾಕು. ಥರ್ಮಿಯಾನಿಕ್ ಎಮಿಷನ್, ಫೀಲ್ಡ್ ಎಮಿಷನ್, ಫೋಟೋಎಲೆಕ್ಟ್ರಿಕ್ ಎಮಿಷನ್ ಹೆಸರು ಬರೆದ್ರೆ 2 ಮಾರ್ಕ್ಸ್ ಸಿಗ್ತದೆ. ಪಾರ್ಟ್ ಬಿ ಅಲ್ಲಿ ಬರುವಂತ ಕ್ವಶನ್. ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಪಾರ್ಟ್ ಬಿ ದಲ್ಲಿ ಬರುವಂತ ಕ್ವಶನ್ ಥರ್ಮಿಯಾನಿಕ್ ಎಮಿಷನ್. Photoelectric emission is a content of this chapter. Remember, ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ನಾವು ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಎಮಿಷನ್ ಅನ್ನು ತುಂಬಾ ಡಿಟೇಲ್ ಆಗಿ ಸ್ಟಡಿ ಮಾಡ್ತೇವೆ. ಈ ಫಿನಾಮಿನಾ ನಾವು ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಫೆಕ್ಟ್ ಅಂತ ಹೇಳ್ತೇವೆ. ದಿಸ್ ಇಸ್ ಅ ಪ್ರೊಸೆಸ್. ಅಲ್ಲಿ ಫಿನಾಮಿನಾ ಅಂತ ಹೇಳ್ತೇವೆ, ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಫೆಕ್ಟ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಈ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಫೆಕ್ಟ್ ಅನ್ನ ಬೇರೆ ಬೇರೆ ಸೈಂಟಿಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರು. ನಾವೊಂದಿಷ್ಟು ಪ್ರಾಕ್ಟಿಕಲ್ ಆಗಿ ನಮ್ದು ಒಂದಿಷ್ಟು ಎಕ್ಸ್ಪ್ಲೇಷನ್ ಇದೆ. ಐನ್ಸ್ಟೈನ್ಸ್ ಎಕ್ಸ್ಪ್ಲೇಷನ್ ಸ್ವಲ್ಪ ಇದೆ. ಆಲ್ಬರ್ಟ್ ಐನ್ಸ್ಟೈನ್ಸ್ ಎಕ್ಸ್ಪ್ಲೇಷನ್ ಸ್ವಲ್ಪ ಇದೆ. ಫಾರ್ ವಾಟ್ ಹಿ ಗಾಟ್ ನೊಬೆಲ್ ಪ್ರೈಸ್. ಅದಕ್ಕೆ ನೊಬೆಲ್ ಪ್ರೈಸ್ ಸಿಕ್ಕಿದೆ ಅಂತ ಡಿಸ್ಕಷನ್ ಮಾಡಿದ್ದೇವೆ. These two, just we have to remember definition. What is thermionic emission? Thermo means heat. Thermo means heat. Thermo means heat. Thermionic emission means what? Emission, let me repeat. Thermionic emission means what? Emission of electron by supplying heat. What is it? Heat is form of energy. That's what I am telling. By supplying energy. By supplying energy, you can remove electron. Here thermoelectric emission. Thermoelectric emission means what? It is a process of removal of electron. It is a process of liberating electron from metal surface by supplying heat energy. By supplying heat in the form of energy. I mean supplying energy in the form of heat. Sorry. By supplying energy in the form of heat. So to say, I can define thermionic emission. It is process of emission of electron by metal surface by applying heat energy. By applying heat energy. Thermo means heat. Heat energy. When you supply heat, atoms get excited. Those outermost electrons, free electrons, will jump from the metal surface by gaining electron. I mean by gaining energy. Those electrons will jump out of the surface. This is called thermionic emission. By supplying heat, electron can be liberated, electron can be removed. What is field emission? Here field means electric field. Electric field. by applying very high electric field. Very high means what? It's given roughly